You know that feeling, right? A huge new AI model drops and bang, your feeds just explode. Headlines, benchmarks, everyone's talking.
Yeah, it's like this wave of buzz hits you. A mix of excitement, but also, okay, where do I even start with this?
Exactly. Because for those of us actually using these things, needing AI to, fix a real bug, understand a chart, solve a tough research problem,
And stay on budget. That's the key.
right. The question isn't just, is it cool? It's what really matters here, beyond the hype.
It's that jump from the shiny demo to, okay, does this thing actually pay rent in production? Can it reliably do the job?
Which is exactly why we're doing this deep dive today. We want to cut through all that noise and look at the very first independent data on GPT-5's performance.
Yeah, our mission here is pretty clear. We're treating these benchmarks not like trophies on a shelf, but like precision instruments. You need to know how to read them.
We want to give you a kind of field guide for analyzing them, show you where GPT-5 is genuinely ahead, maybe where it lags a bit.
And crucially, how those differences hit your bottom line, the cost, the speed, the reliability you actually get.
And we're grounding this whole discussion in some solid data. This comes from an independent analysis by Azmat at Binary vs. AI. It just came out August 10th, 2025.
Right, and it's a direct comparison. OpenAI's official claims for GPT-5 versus third-party numbers from the VALS AI benchmark suite. The data itself is super fresh, like August 8th.
So no guesswork. We're aiming to give you the essential nuggets, the actionable stuff you need to make smart decisions for your own work.
Exactly. Let's help you navigate this without just throwing darts.
Okay, so let's start by getting our bearings, comparing the official story with what the independent checks are showing, kind of calibrating our view.
Good starting point. Where should we begin? Maybe SWE-bench.
Yeah, let's do that. SWE-bench verified, that's the one simulating fixing real software bugs in a repo, right? OpenAI claimed a pretty impressive 74.9%. What's the independent take?
Well, that's the interesting part. Right now, that 74.9% is the only number out there. VALS.ai hasn't independently verified it yet.
Ah,
They do say it seems plausible, kind of lines up with other things they're seeing from GPT-5, but yeah, it's still technically unverified independently. Something to watch.
got it. Okay, moving on to math. AIME 2025, this is that tough one. Multi-step reasoning, no calculators or tools allowed. OpenAI said 94.6%.
And VALS came back with 93.4%. That's really close.
Very close indeed. Seems like a strong confirmation there.
Definitely. It confirms GPT-5 is operating at that S-tier level for mathematical reasoning. Super important for analytical tasks.
And then GPQA. Also, no tools, designed to be hard to bluff. Testing deep research Q&A stuff. Official, 85.7%.
VLS, 85.6%.
Yeah.
Practically identical.
Wow, okay, that's remarkable alignment again. Strong confirmation on its high-level reasoning.
Absolutely. The consistency there is quite telling.
Now, this one's interesting. MMMU Pro, broad academic knowledge benchmark, good proxy for, general educated work. OpenAI didn't report a score.
Right, they were silent on that one.
But VLS AI did test it. They found GPT-5 gets a strong 87.0%. So
Yeah.
why the silence from OpenAI, maybe? And what's the story here?
That's a great question. We don't know why OpenAI didn't publish it. But the VLS score shows, yes, it's very capable. However, it actually places just behind Claude Opus 4.1 on that specific benchmark. So even with a strong score, it's not necessarily #1 across the board. Highlights the competition.
Right, okay. So it's strong, but there's nuance. And finally, MMMU Multimodal Understanding, reading charts, diagrams, blending text and visuals. Official 84.2%.
VLS came in at 81.5%.
So directional alignment there too, both very high scores. VLS maybe a touch more conservative.
Exactly. It clearly shows a strong capability in handling that mix of visual and text information, which is increasingly important.
Okay, so that gives us a baseline, how GPT-5 looks against its own claims and these first independent checks. But the real question is, how does it stack up against the other big players, using that fresh VLS AI data from August 8th?
Yeah, let's look at the VALS leaderboards. GPT-5 definitely has clear leads in a couple of key areas. It's #1, undisputed, on AIME 2025 math with that 93.4%.
Okay, top for math.
And it also takes the top spot for MMMU, multimodal, with 81.5%. So if your workload leans heavily on precise math or complex visual analysis, GPT-5 is currently leading the pack there.
But like you said, no single model wins everything. Where do others have an edge? You mentioned Grok 4.
Absolutely. Grok 4 really stands out on GPQA. That's super hard research Q&A. It's #1 there at 88.1%.
That's interesting.
It also leads on Math 500, which is a different but still advanced math benchmark, scoring 96.2%.
Okay, so Grok has its strengths in deep reasoning and perhaps certain types of math. What about Claude?
Claude Opus 4.1, as we mentioned, leads on MMMU Pro, that broad academic knowledge test, with 87.8%. So if that specific capability is your absolute priority.
Then Claude might be the leader for that specific task.
Okay.
And this all happens against a backdrop of cost, right? We should probably touch on those numbers.
Definitely need to. So GPT-5 is priced at 1.25 TERP per million input tokens and $10 per million output tokens.
Okay, how does that compare?
Well, Claude Opus 4.1 is significantly pricier. $15 for input, $75 for output. Big difference.
Whoa, yeah.
Grok 4 is $3 for input, $15 for output. Gemini 2.5 Pro Experimental matches GPT-5's pricing exactly. And then you have GPT-5 Mini, which is way cheaper, like 5 cents for input, 40 cents for output.
Right. Those price differences are huge. They absolutely have to be part of the calculation. It's not just about the scores.
Not at all. They set the rhythm for how you use these things economically.
Okay, so we've got the scores, the comparisons, the costs. But like you said, these numbers, these benchmarks, they're instruments. Use them wrong, they just make noise. How do we use them right? How do we, as builders, turn this into something truly useful?
Yeah, it really comes down to adopting a few key habits when you look at this stuff. Habits that turn data points into real signals for your work.
Okay, what's the first one? You mentioned thinking modes, not monoliths. GPT-5 having a quick gear and a deep gear. What's the trap if people don't grasp that?
The biggest trap is treating every single prompt the same. Like sending a simple classification task and a complex code generation task to the model with the exact same settings.
Right.
GPT-5 isn't just one engine. It has that quick gear for fast, simpler stuff and a deep gear for heavy lifting, more reasoning effort. That choice dramatically changes the quality and the cost. If you don't get that, you'll either waste money asking it to think deeply on easy tasks, or get poor results by not giving it enough reasoning power for hard ones. Honestly, a lot of the variation you see in GPT-5 benchmark results comes down to which gear was used and whether tools were on or off.
That's a really crucial distinction. Okay, second habit. Retrieval is your anchor. Why is adding that retrieval layer before prompt tuning so vital?
Think about it. If the model doesn't have easy access to the right context, the right information, what's it going to do? It might hallucinate, or it might need way more tokens, more internal thought to try and figure things out.
Makes sense.
Putting a retrieval layer in first is like giving it a perfectly organized library for the specific task.
Yeah.
It makes the answers much more stable, cuts down the tokens needed a lot, and it's probably the biggest quiet money saver when you look at the total cost per solve for GPT-5. It's foundational.
Yeah, that sounds essential. Which leads nicely into the third habit. Total cost beats token price. It's tempting to just grab the cheapest model per token.
Super tempting, but often a mistake. It's like buying the cheapest tool that breaks after one use versus one that costs a bit more but lasts for years.
Right.
A model that's cheap per token but fails half the time, needs multiple retries, needs a human to fix its output. That ends up costing you way more in compute, developer time, and delays than a slightly pricier model that just gets it right the first time.
So you always need to calculate the total dollars per successful outcome.
Exactly. That's the number that actually matters in a business setting. That's the real bottom line.
Okay, and the last habit. Hold out a private set for evaluation. This sounds like keeping a secret test stash. Why is that so important? What's the risk if you don't?
The risk is basically fooling yourself. It's called teaching to the test. If you tune your prompts and evaluate your model using the same data or very similar data.
You're optimizing for data it's already seen?
Precisely. You might get fantastic scores on your internal tests, but then it falls flat on its face when it hits truly new, unseen data in the real world in production.
Ouch. So how does a smaller team do this simply?
Just keep a small set of examples, maybe 5, 10 per core task, completely separate. This set never gets used for prompt tuning or iteration. It's your honest, uncontaminated reality check. Your private benchmark.
Okay, those habits made a lot of sense. Think in modes, anchor with retrieval, focus on total cost, and keep a private test set.
Got it. Now let's apply this. Let's take some specific benchmarks and run that so what test. What does performance here mean for tasks you actually do?
Sounds good. Let's start with coding SWE-bench verified again.
Right. Task.
Yes.
Read a real repo, understand an issue, produce a patch that passes tests. OpenAI claims 74.9% for GPT-5, high reasoning effort, fewer tool calls, fewer output tokens, strong claim.
It really is. And it's not just about spitting out code. It implies the model can make a plan, look at the right files, patch them correctly, run tests, summarize, without just flailing around. It suggests a more intelligent agent. And, okay, here's where it gets really interesting. Translating that to business value. What does that 74.9% mean for a team?
It means efficiency, pure and simple. Fewer retries means less wasted compute, lower cloud bills. Shorter chains of interaction mean less developer time babysitting the AI.
Which translates to two.
Shorter shipping times for features. Senior engineers freed up from boilerplate code to work on harder problems. Feature branches merging faster. Hot fixes getting out quicker. It's a win on the calendar, which usually becomes a win in the market.
That's huge. And for teams wanting to replicate or track this internally.
Log everything. Prompt version, reasoning mode, the exact list of tools available, any tool errors, the test harness version. Details matter for reproducibility and tracking progress.
Okay, let's switch to math. AIME and Math 500. These test deliberate reasoning, not just facts. GPT-5 is S tier on VLS, tops AM, 93.4%. Second on Math 500, 96.0%, just behind Grok 4. What's the business value of that kind of precision?
It means the model's internal scratchpad is much cleaner. Fewer silly arithmetic mistakes in the middle of a complex calculation. More reliable intermediate steps.
So in practice, for like an analytics team.
Cleaner revenue forecasts, steadier cohort analysis, fewer of those painful data pipeline regressions that bite you at the end of the month. Your BI dashboards are just more trustworthy.
Less time spent double-checking the AI's math.
Exactly. It builds trust in the numbers the AI generates, which leads to faster, more confident decisions based on that data.
But you mentioned a potential issue with AIME, data contamination.
Yeah, it's a known thing. AA questions are public, so models might have seen them during training. That's why you can't rely only on AA.
Right.
You use it directionally, but you pair it with MAT 500, which is less exposed, and ideally your own small set of internal private math problems that the model definitely hasn't seen. That keeps your evaluation honest.
Good point. Okay, knowledge and reasoning. MMMU Pro and GPQA. Two different lenses. MMMU Pro is broad, general knowledge. GPT-5 strong at 87.0% on VALS, but just behind Claude 4.1. Does that small Claude edge matter?
It could, but probably only in very specific cases. Like if your entire product is a general knowledge chatbot where latency is absolutely critical and MMLU-style questions are 90% of the traffic, then maybe that small lead is tempting.
But GPQA is different. Harder to bluff. Deep research Q&A, Grok 4 leads there, 88.1%. GPT-5 close behind, 85.6%. So if your main job is deep research...
And you definitely want to start your bake-off comparing Grok 4 and GPT-5 using GPQA-style prompts. See which performs better on your kind of research questions.
But you wouldn't just look at GPQA, right?
No, you have to weigh that against how well they use tools, how good their coding is, the cost. Many teams might still pick GPT-5 even if Grok edges it on pure GPQA because the overall package coding tools, maybe multimodality fits their broader needs better.
So again, no single winner. It depends entirely on the job.
Exactly. There's no single crown. MMLU Pro suggests GPT-5 is a strong generalist.
Yeah.
GPQA suggests it's a capable second brain for deep dives, maybe acting like an internal red team to challenge assumptions without weeks of memo writing.
Got it. And the last category, multimodal MMMU. Reading charts, diagrams, blending visuals and text. Stuff we see in reports constantly. GPT-5 leads here, 81.5% on VALS, just ahead of Gemini 2.5 Pro XDELI.
Yeah, this is a really practical capability. It means the AI is less likely to just say, here's an image, and more likely to say, okay, looking at this chart, the key trend is X, and that outlier Y is probably because of Z.
Fewer what am I looking at moments, more actual insight.
Right, guys.
And the business value there feels subtle but potentially huge.
I think so. Think about analyst co-pilots instantly understanding dashboards, unlocking insights from data currently trapped in PDFs or images, faster customer support because the AI can understand screenshots, field text, getting info from complex diagrams on the spot.
It turns all those inert documents and images into active, searchable surfaces.
Exactly. It's a quiet, strategic advantage. You're leveraging information you already have, but couldn't easily use before.
Okay, this keeps coming back to the idea that a slightly lower score might not matter if the model is more efficient overall.
Absolutely. A model that's 1 point lower on a leaderboard but needs half the retries or uses tools more reliably is often the better choice in production. It all comes down to cost, speed, and that final number. the cost per successful solve.
Let's revisit that cost example. A typical coding ticket, maybe 10K input tokens, 2.5K output tokens. With GPT-5's pricing, 1.25, $10 per $1,000,000, that's about,
Roughly 4 cents for a clean, successful solve. Seems tiny, right?
yeah, 4 cents. But the key is, if another model needs more retries or generates much longer outputs or calls tools unnecessarily.
That 4 cents can easily become 8 cents or 12 cents or more. And remember, output tokens are way more expensive than input tokens for GPT-5 $10 or 1.25 per million. A model that's just more concise in its answers saves you real money on the expensive part.
And when you multiply that difference by thousands or millions of tasks per month,
That gap pays salaries. That's the scale we're talking about. It's not trivial at all.
which is why just looking at accuracy misses the point.
Completely. You have to track time to success, total tokens used, input and output separately, the number of tool calls, and the number of retries needed. Those metrics tell the real story for your use case, much more than a simple accuracy bar chart.
Okay, so this sounds like something teams need to do themselves. What does this mean for you listening? You don't need a giant research budget to check this out for yourself, right?
Not at all. You can run a meaningful independent verification in about a week, even a small team.
How? What's the method?
First, pick maybe 4 core tasks that really represent your work. A repo patch, some data analysis, maybe a multimodal question from a report, a deep research Q&A. Make them realistic.
Okay, 4 real tasks.
Then, create maybe 5 to 10 specific examples or test cases for each task. And remember, our habit? Keep 2 of those cases hidden. Set them aside for the final, honest check.
Right, the private set. Then what?
Run GPT-5 on your test cases. Do it in both modes, the quick mode and the deep reasoning mode, probably with tools enabled for the deep one. And do the same for your main competitors, the runner-up models you're considering.
And while running them,
Log everything: input tokens, output tokens, tool calls, latency, time to get the answer, and a clear pass-fail based on your specific success criteria. Be meticulous.
then comes the math.
Yep. Calculate the cost per successful solve for each model, for each task in each mode. Use the actual token counts you logged and the vendor's pricing. This shows you the true economics.
And finally,
Write it up. A simple 2-page memo is fine. Include tables with your results, clearly state the settings you used, model version, reasoning mode, tools, maybe link to your test harness code if you can.
that's your internal proof point.
Exactly. And then crucially, don't just do it once. Rerun that harness every month or whenever a vendor drops a major new model version. Add a little changelog to your memo. That turns it into living documentation that everyone, engineers, product managers, budget holders can trust.
That sounds incredibly practical. And if you do decide to share your findings more broadly, what makes benchmark results trustworthy, like a builder's checklist for publishing?
Good idea. First, transparency is key.
Right.
State your dataset snapshot dates. What reasoning mode did you use? What tools were available? What was your grading process? Any timeout?
To include the efficiency metrics too, right?
Absolutely. Don't just show accuracy. Show the token counts. Show the tool call counts. That paints the full picture.
And the cost.
Yes. Show the money. Quote, the cost per solve for at least one realistic task. Make the economics clear.
What else?
Be honest about limitations. Did you have to omit any test cases? Say why. Label clearly if results are from the vendor, official, or your own testing independent, and link your sources.
And the changelog.
Always include a changelog with dates.
Yeah.
It shows you're maintaining it and builds huge trust. That's how you turn marketing numbers into real engineering data.
Okay, awesome. Let's wrap this up. Let's tie it all together. Bottom line, if you're making a choice this quarter, what's the takeaway?
Well, if your typical week involves a lot of coding support, building agentic workflows, working with documents, GPT-5 looks like a very strong default choice right now.
Why?
Because the independent numbers generally back up the official story in those builder-centric areas. Strong coding means fewer retries, tool use seems steadier, long context retrieval is solid, multimodal is sharp for real-world analyst tasks,
Wow.
but you still need to run your own tests. Use your own harness, apply your own budget lens, verify it for your specific stack and workload before you fully commit.
Okay, what if your week looks different? More focused on deep research Q&A, maybe with few tools, or maybe your product relies heavily on general knowledge accuracy.
Then you get a more complex decision. It's likely a bake-off. Frame it as GPT-5 versus Claude 4.1 if broad knowledge chat, like MMMU scores, is paramount. Or frame it as GPT-5 versus Grok 4 if it's all about that diamond-hard research Q&A where GPQA shines.
And the deciding factor.
Compare them head-to-head on your data, looking not just at accuracy but critically at the total cost per successful solve and the time it takes to get that success. Factor in the economics. Usually the best answer for you becomes pretty clear once you do that.
So it really hammers home that benchmarks aren't the absolute truth.
Exactly. They're not reality itself. They're more like stories about reality, told with numbers.
And the trick is?
The trick is to pick the right story for your specific job, the benchmark that actually reflects what you need the model to do. And then you have to keep checking, does that story still hold true next month or after the next model update?
Do that, and GPT-5 benchmarks, or any benchmarks really, stop being this confusing debate.
Yeah, they become just another tool on your workbench, a useful, cleaner instrument you can rely on alongside your profiler and your debugger to help you build better things.
That's a great way to put it. So take this knowledge, apply these habits, run your own tests, and really understand the instruments you're working with. Don't just trust the hype, build your own understanding.